Hi, I'm Ella, and today we're going to be talking about carbon dioxide and its Lewis dot structure. We're also going to be talking about its 3D structure along with its electron pair geometry, molecular shape, and ideal bond angles. We're also going to talk about whether it is nonpolar or polar and also its intermolecular forces. So to start out, we're going to talk about the Lewis dot structure. So carbon has 4 valence electrons and oxygen has 6, and we're going to multiply that by 2, so we get 16 valence electrons. So we're going to start by putting carbon in the middle because it is the least electronegative, and then we're going to put oxygen on both sides. So to start, we're going to put one bond between this carbon and oxygen and another bond between this carbon and oxygen. And then we're going to put the rest of the electrons around oxygen. So now we're going to check for octets. So this oxygen has an octet and this oxygen has an octet, but carbon does not. So what we're going to do is we're going to put these 2 electrons and we're going to create another bond between this carbon and oxygen, and we're going to do the same on the other side. So now we'll redraw it, and there will be 2 bonds between here and 2 bonds between here, and then the remainder of the electrons. And now there is a formal charge of 0, and there's your Lewis dot.
On the screen, we have the 3D structure of carbon dioxide. So the number of structural electron pairs that carbon dioxide has is 2. So that makes the hybridization of the central atom, which is carbon, that makes it sp. So because of that, that makes the electron pair geometry linear and the molecular shape linear as well. And the ideal bond angles are 180 degrees. Carbon dioxide is nonpolar, and this is because its dipole moment is 0. The dipoles point in opposite directions, so they cancel each other out. So therefore, the only intermolecular forces present are the London dispersion forces.